hitting that screen, tap, 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 because we need to let everybody know that Professor TK the chemist is in the building and that we're getting ready to do what? Learn chemistry. Oh, thank you. Thank you so much for real. I appreciate you for real, TX. I appreciate that. And you have an amazing day as well. So, guys, what we're going to do, we're going to have a lot of fun. Yes, as you guys can see, I am online. So let me go ahead and switch back to my other screen here because we need to go ahead and get into this lesson today. And I want to make sure that you all are going to get what you came in here for, okay? So today, what we've got here is a lesson on solubility rules. And I know so many students don't know what solubility rules are and how they can address those rules. So I'm going to actually go through them and give you guys some quick tips today, okay? And if you all need further assistance, you all know what to do, right? Hit that link in my bio so you can get some one-on-one attention, okay? So here's what I've got. No, well, it is to a certain extent, Shohag. So let me say this too. I'm glad you asked that question. So here's the thing. In chemistry, many of you guys know already that chemistry is repetitive. It comes back in many different ways. So what you're learning today will show up on your final exam, yes. But also what you learned several weeks ago comes back in another way. For instance, if you learned how to balance chemical equations, if you did all of that stuff like and with ease and you understood it, guess what? It comes back in the form of net ionic equations. Also, writing out chemical reactions, that comes back during this particular lesson as well. And so many students get this confused because they didn't learn certain rules. So when it comes to net ionic equations, you got to make sure that you keep in mind that it deals with balancing chemical reactions and knowing certain rules as it relates to solubility and insolubility. So indirectly, yes, 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 yes. So now, thank you guys so much for the shares and for the follows. Hello, Hood Professor. Hey, Steve. Hey, Raj. Hey, Shine NNY. So what I'm going to get you guys in today. Okay. All right, Purple Love. Well, what are you learning in chemistry? Talk to me. What you need to know. So for those of you all that are popping in right now on my lesson, I am going over some chemistry rules. And what this deals with are the solubility rules for net ionic equations. You said everything. Okay. Well, listen, you're going to have to DM me, honey, so I can get you on the right track. Yes, yes, yes. So, because this lesson here is actually something that deals with getting towards the end of the semester on solubility and on writing chemical equations. So I want y'all to repeat this word after me. Nag-sag. I know that sounds like, what? Oh, you're welcome, honey. You're welcome, Purple Love. And I like your name because purple is my favorite color. Matter of fact, I'm rocking purple today. Now, I can't turn the camera on, but, you can kind of see it right here. Okay? Got on some purple today. Yes, purple is the color for royalty. Yes. So if you say nag, sag, that is a mnemonic to help you guys remember these solubility rules. So let me go ahead and zoom in a little bit so y'all can see and read the screen. And I will post this up later, on TikTok. Okay, so I will be posting this up later for you guys to see. But with these solubility rules, here's what you need to know. NAG, SAG stands for nitrates, acetates, group 1 elements, sulfates, ammonium, group 17 elements. So what that means is those elements are soluble, okay? Soluble compounds. That means they will dissolve. So for instance, if I am making, let's say, salt water, and you guys know when you add salt to water, Salt tends to be dissolvable or soluble rather in water. You shake it up and you can let it be where you don't even see the salt anymore. The sodium and chlorine ions will detach themselves from water, thus an aqueous solution. So what you've got with these solubility rules is that if you remember that nitrates are soluble, acetates are generally soluble, group 1 elements, like I just said, lithium, sodium, potassium, etc., they're soluble salts. Sulfates are soluble, except when they connect with calcium, barium, strontium, and lead. And then you got ammonium, and they're always soluble. And then your group 17 elements, okay, those are your halogens, like chlorines, bromides, and iodines. They are also soluble, except for when they are paired with silver, lead, or mercury. Okay, so if you can remember NAG/SAG, that's going to help you remember the acronym for those rules. So let me again highlight this for you so you all can see that. Okay, so NAG/SAG. Again, that means your nitrates, acetates, group 1 elements, sulfates, ammonium, and group 17 elements. Now, there's always a time when things don't always dissolve. So like if I take a penny, okay, or some copper, let's just say that, copper, and I put it in some water, it's not going to dissolve. And here's why. Here's why. These are your solubility rules here as well, the exceptions to the rules. So if you've got lead 2 sulfate, silver 1 sulfate, calcium sulfate, PAC, think PAC, PAC, that stands for lead, silver, and calcium. Those are insoluble. See, we told you that up here when we talked about the insolubility, the sulfates that are insoluble, okay, with those particular elements. The halides of silver, lead, and mercury. Think of HSL, heavy silver lead. Those are also insoluble, okay? So if I think about putting silver in water, you're going to see that silver going to the very bottom, lead going to the very bottom, mercury. Hey, how many of y'all remember mercury thermometers? Okay, they don't make those anymore. Those are poisonous. Okay, let somebody break one of those. You're going to have the hazmat team come in. Okay, that's insoluble. Your carbonates and phosphates, oxides, and hydroxides are also insoluble, except those of group 1 elements and ammonium. So in other words, if you combine group 1 elements and ammonium with any of those are going to be soluble, okay? Hello, Alexis, my other chemist professor. How are you doing today? So, if you guys remember these rules, okay? As we say, the rules of engagement. This is going to help you guys when it comes to the solubility rules, okay? So you want to make sure, gas stoichiometry, yes. That should be fairly simple. The gas stoichiometry rules. So as long as you guys remember these rules here, they will actually help you. So of course, we're going to take a little quiz, okay? And I'm going to see what you guys can remember. All right? So, I don't want y'all to see the answers. I was moving the screen too quick. So here's what I want to know. Okay, let me zoom in a little bit so y'all can see this, okay? You're going to predict the solubility of the following compounds in water. So let's take a look. Lead to nitrate. Lead to nitrate. Is that soluble in water or insoluble? So think about the rule for lead, okay, and nitrates. If you go up here to what we were talking about before, NAG/SAG, nitrates, and then we talked about leads, okay, but it's only concerning sulfate attachments. So is lead to nitrates soluble or insoluble? Okay, I see Shohak said soluble. Okay, what we're going to do, we're going to put the answers beside it before I reveal All of them, because the answers are going to pop up for everything. So Showhawk said soluble. All right. Anybody else agree or disagree? So I'm going to put off to the side S for soluble for that one, and we're going to check our answers momentarily. Okay, let's take a look at the next one. Calcium carbonate. Calcium carbonate. Is calcium carbonate soluble, meaning it will dissolve in water, or insoluble, meaning it's not? Hey, Tay, I think I just saw Tay come across my screen. Okay, so take a look. Let's go back to our rules here. Calcium carbonate. Carbonates are insoluble except for those of group 1 elements and ammonium. So let's see. Is calcium. Calcium is not a part of group 1, but is that soluble or insoluble? Again, put your answer, put S for soluble and I for insoluble in the chat box. So let me know what you guys think. Is calcium carbonate soluble or insoluble? S for soluble, S as in Sam, I for ignore or ice, for insoluble. And maybe y'all don't know, all right? So I'm going to help you guys out, okay? Since we were looking at the rule for calcium carbonate up here, we saw where it says carbonates are insoluble except for those of group 1. Well, calcium is not a part of group 1. So maybe that one is insoluble. So I'm going to put an I. Okay, I'm going to put an I there for that one. Okay, what about potassium chloride? Potassium chloride. Let's go up here to our rules and let's see. Potassium chloride. Okay, potassium is in group 1. Chlorine is also in group 17. So I believe that is soluble. Okay, I'm going to put an S for that one. Put an S for potassium chloride. And then we've got the last one here, the last example, silver chloride. Silver chloride, is that soluble or insoluble in water? Yes, Jaden, that is correct. Neutralization, yes. And I've got one coming up shortly. So if you're talking about an acid like HCl plus a base, let's say magnesium hydroxide, you always want to keep them together when it comes to balancing them out. Whoops, you can't see that what I'm writing. You always want to keep them together for what you're balancing them out, so that you can balance them a lot easier. Okay, good, Jaden. Good. But yes, you want to keep your polyatomics together. It just makes life easier. And this is an example of a polyatomic ion, hydroxide. If you got any more questions, Jaden, after your test, come holler at me. Okay, guys, that was quick. So now, you're welcome, honey, you're welcome. So now, if we look back at silver chloride, what do y'all think about silver chloride? Is that soluble or insoluble in water? So if I look at again, the rules, silver chloride. Halides of silver, heavy silver lead. Silver, lead, mercury. Those are all insoluble. Even though you see chloride here that says that chlorides are soluble, it said except when paired with silver, lead, or mercury. So guess what? I'm going to take a guess. I'm just going to say it's insoluble. So let's see if these are correct. So I only had one response from one student from Shohag that gave me the first one for lead 2 nitrate. So let's see if we are correct here with our answers. All right, so right here it tells us that lead 2 nitrate is soluble because nitrates are always soluble. So we got that one correct. Okay. Calcium carbonate is insoluble because carbonates are generally insoluble except for those that are part of group 1 or ammonium. So we got that one correct. Potassium chloride is soluble. Well, because all salts of group 1 are soluble and chlorides, unless you have it paired with silver, lead, or mercury. So we got that one correct. And then the last one, silver chloride is insoluble because halides of silver, lead, and mercury are insoluble. So we got all 4 of those correct. Now, here is the deal though. If you are given examples like this, make sure that you have your sheet nearby. Most chemistry books have them. In matter of fact, all chemistry books, general chemistry books, should have these rules in them to make life easier for you to understand and remember these rules. Now, I do have some more examples. We're going to make sure that we are doing the right thing with these examples here. So again, because I'm going to give y'all a quiz at the end. It says barium sulfate. Okay, so we just talked about this. Is barium sulfate soluble or insoluble? And as you guys can see, here's the answer. It is insoluble. Okay, and here's why. Generally speaking, when you have sulfates are generally soluble, except when you pair them with barium, calcium, and strontium, and also lead. So that's why barium sulfate is insoluble. Now, the reason why I'm putting that there is because when we get to those examples where we're doing net ionic equations, these rules will come into place. These rules will come into place, okay? So you want to make sure that you know these rules before we do the net ionic equations. So let's take a look at the next one. Ammonium phosphate. Now, we've talked about ammonium for a minute, okay? You've heard me reference that. So is ammonium phosphate soluble or insoluble? Well, let's see. Ammonium compounds are always soluble. So we got the first part of that. Ammonium is always soluble, okay? There are no exceptions for ammonium. So yes, ammonium phosphate would be soluble. Now, if we go back up here, okay, for what they were talking about with the phosphates, those tend to be insoluble except for those of group 1 and ammonium. So that's why this answer is what it is, okay? When they give you the exceptions, you need to make sure you understand that, okay? Is it insoluble in all solvents, Verb asked? Is what insoluble in all solvents? Okay, the third one, silver iodide, silver. Okay, is barium sulfate insoluble? So yes, barium sulfate is insoluble. And this is specifically dealing with aqueous solutions like water. So when you hear the word aqueous, that means this particular substance dissolves in water. And normally, whenever you write out some of these compounds, if they are insoluble, then those are going to be written with an S at the end in terms of their physical states. But if they are soluble, like in this example here for ammonium phosphate, then you would write AQ because it can break up. User 22, I do tutor in chemistry 2, but I don't teach chemistry 2. Oh, yeah. Are you in general chem 2 right now, user 22? You're welcome, Burb. You're welcome. So now if we look at silver iodide, okay? Silver and iodine. Let's look at silver. We know that we already told you that silver did what? It wasn't soluble. Okay, they told you right there. It wasn't soluble. But now when you talk about the iodide, okay, that's group 17, those are soluble. But when you combine the two together, silver iodide will not be dissolved at all. So silver iodide is insoluble. Okay, well, if you got questions, user 22, let me know. Please do reach out to me. Like, I know it's probably getting to the end of the semester right now, and so you're trying to prepare for your final exams, but let me know. Okay, let me know. Yes, because you guys don't have to struggle. Anytime you're taking classes that are difficult, always seek out help from your chemistry professors, always from your teachers, always. I know that sometimes some of your teachers make things difficult or uncomfortable, but they're the ones giving you the grade at the end of the semester. So I would be in their office every week during office hours. Leslie Jeremiah said, I'm a chemistry major, graduating MA. Yes. Woohoo! I love chemistry so much, and I love that you're doing this. You're welcome. You are so welcome. And Jeremiah, if you don't mind, let me say this. Make sure you give back. Okay. What are you doing after you graduate? What do you plan to do? Are you going to go to grad school or are you going to start working? You're welcome, user 22. What's going on, Cecile? How you doing? We got another chemist in the building. Cecile said, oh, my professor is too sassy to ask for help. Well, let me tell you something. I mean, took points off for showing your work. Oh Lord. Well, you know what? Mm, mm, mm. I don't know. Some like I said, some teachers just be on a different wavelength. Unfortunately. You gotta show me your test. If you can, DM me screenshots of your test if you can. Hey Bridget, how you doing today? Oh, a lab. Well, still show it to me. DM me and so I can see it. Now, example 4, magnesium hydroxide. Okay, check this out, y'all. Do you know that if you have a bad stomach ache, it's ironic that I think Jaden, I think that was the person that was on here. They actually asked me a question about neutralizations. And do you all know that magnesium hydroxide is one of those key ingredients that's used in Pepto-Bismol? So if you have an upset stomach, you can take Pepto-Bismol and it'll actually coat your stomach and form a salt. And also, I use magnesium hydroxide whenever I'm formulating deodorant. Matter of fact, I don't even have, yeah, I could have showed y'all an example, but yes. Okay, Giselle said you wrote the net ionic and I wrote the complete one and the net ionic below it, but I circled it. Oh, yes, 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 yes. Yes, oh, yes, bismuth is in Pepto. And I got a little element of bismuth that I have on my desk. You know, y'all got me. I'm gonna have to show y'all. Not right now, but I'm gonna have to do a video on that. Yeah, and you know what, Giselle, the fact that you circled it, and even though you showed your work, hopefully they didn't mark it all the way wrong and just took out partial credit because you did show your work. I would hope that that was what was happening. So when you look at magnesium hydroxide, magnesium, okay, that's in group 2, right? But they also told you hydroxides. We mentioned something about hydroxides. Hydroxides are generally what? Insoluble. Hydroxides of group 1 elements and barium are soluble. So in other words, if you've got barium, okay, because that's in group 2, only that element. But then you got group 1 elements paired with your hydroxides, then they are soluble. But in this case, no. Magnesium is insoluble with the hydroxide, okay? So now let's go ahead and get to some other examples really quickly right here. I've got some other ones that I wanted to do, but I'm going to go ahead and show you guys some net ionic equations, okay? So let me go ahead and share a different screen here so that we can do those examples. Let me make sure this is the one. Yep, this is the one. Okay, so let's see. Jemima, you said you're going to get your MD, PhD in the fall of 2025. After graduating, I'll be working in a lab furthering my Alzheimer research. Woo! I got to snap it up for you, honey. Excellent, excellent, excellent. I love to hear that. I love it, love it, love it. You must be smarty art for sure, for sure. So you must want to become a doctor. You wanting your MD and PhD, Alzheimer research, and that's deep. Alzheimer research is nothing to play with. So many of our elders are getting hit with this disease. And it's good that we have young people like yourself wanting to make a difference. And I so appreciate that. I appreciate you for wanting to pursue that further. All right, guys. So when we have examples like this, and they're giving you a molecular equation, you're welcome. You're welcome. When you're given molecular equations like this, okay, first off, let me show you. Sometimes I'm going to scroll down to this one really quickly so you can see what some of your teachers will do. They'll give you an example like this right here, okay? And they're going to give you the words, and then they're going to tell you to write out the molecular equation, and they're going to tell you to give the net ionic equation. Here's the deal. If they don't give you, let me zoom in a little bit so you can see. If they don't give you the molecular equation, but they gave you the words, you're expected to know how to do this part right here. Okay? You're expected to know how to do that part simply because we just kind of went over solubility rules. So that would help you in terms of knowing which one of these are going to be aqueous and which one of these are going to be solids. You're welcome, Jaden, and good luck. And let me know how you do, okay? So JC, you just stepped in the building right after I went over predicting solubility. Those are some rules I just talked about. But you know what? I'm going to do one for you. I'm going to actually download part snippets of my videos so I can put it up there in terms of remembering the solubility rules because I just talked about it. Yes, I sure did. Matter of fact, we just did a couple of questions on that. And here were the rules right here. Yes, and that table will help. Yes, yes, yes. Thank you, Blue Butterfly. Thank you, Shawnee. Yes, Jazeel, that's right. A table helps. And not these rules. I meant to say these rules right here. The nag sag. You know, it's like a mnemonic to help you predict the solubility of certain compounds. So now I'm going to go through these examples here for you guys, okay? So that you all can know how to write out these formulas, okay? So here we go, guys. Here we go. So this is your formula right here, and it is already balanced. But if I tell you to write out the net ionic equation for this, here's the easiest thing that you got to do. You're going to split up apart those that are aqueous. And why? Because those are dissolvable in water. And if they're dissolvable in water, that means whatever is left over is going to be your end result, the one that did not dissolve, okay? So you've got sodium here. And I know that sodium has a +1 charge. Oops, you didn't see that. Let me zoom out. Okay, sodium has a +1 charge, but because of that subscript of 2, you're going to put a 2 right there in front of that compound. Okay, and that's AQ plus sulfate. The sulfate ion is SO4 with the 2 negative. And again, we're going to put that AQ symbol there as well. plus barium nitrate. And barium, okay, we're going to split that up. And barium has a 2+ charge, okay? And we're going to put AQ for that one. And then for nitrate, there are 2 nitrate compounds, okay? Hey, Lexi, I do have videos on enthalpy right here on TikTok. And I also have them on my YouTube channel. Yes, I do. Yes, JC, that's another way to kind of look at it too, but you got to make sure you remember which ones there are. Yep, but you're right for the most part. Yes, you're welcome, Lexi. So you've got your nitrate that you're splitting apart from barium, and we're going to put NO3 with a negative charge in AQ. And look, we're going to keep barium sulfate together. Hey, Key, how you doing? I missed you. I missed you. So you're going to, okay. Email me. You know you got my direct line. So you make sure you email me what you got, what you working on. So this barium sulfate right here, remember, you're going to keep that together. Okay, let me zoom in so y'all can see that, okay? I know, it's not your final. Yeah, we talked about that. I know. Yeah, but tell me what you got on test 3. So for your barium sulfate, that stays together. Remember, we're not going to split that up. You do not split solids nor liquids when you're writing out your net ionic equations. So we're going to keep barium sulfate together, okay? So that's what you guys see me doing right now. Plus, now I've run out of space here because y'all know I write pretty big. And so I'm going to squeeze in right here the 2 sodiums, okay, because we're splitting that apart with the positive charge here. And again, that's AQ plus the 2 nitrates, NO3 negative with the AQ. Now I know it's like, what? Wait, what? So let me break it down for you guys. Whenever you have net ionic equations, anything that says AQ, you split those jokers up. You split them up. You split them apart, okay? Whatever the charge is, you're going to put above it as a superscript, and then whatever to balance it out, you make sure that you put coefficients there. So because we had 2 sodiums, that's where the 2 in front of that comes from, and the charge of sodium was positive. Sulfate was split apart, but we brought the charge there. Barium was split up from nitrate, and there's a charge there as well. Okay, same thing for nitrate. We kept barium sulfate together because it's not dissolvable, okay, in water, and it is a solid, and you don't split solids or liquids up, okay? And then you've got your sodiums and your nitrates that you are splitting up, okay? Now, guess what? Chemistry and accounting kind of go hand in hand. My sister was an accounting major, and that's nothing but math, but just in a different way. Joy to your universe, you can always go back and do what? Watch this video on replay. I do have these replays up on my YouTube channel. So by all means, make sure you go and check out my YouTube channel, Learn Chemistry with Professor TK the Chemist, or hit that link in my bio and it'll take you straight over there. That way you're able to pick these back up. Oh, a forensic accountant. Okay. So you love working with numbers, I see, Miss Nay. Yes, chemistry is interesting. I love chemistry. Just like you love accounting, I love chemistry. Oh, yes, Kia, I remember that. The Broglie's wavelength, Schrodinger's equation. Oh, yeah. Those are mostly, I would say, memorizing the equations that you have to use for those different examples. Now, what we're going to do, we're going to slash out those ions that are the same on both sides. So we're going to get rid of, as you guys can see here, I'm zooming out a little bit so y'all can see the whole screen, but I'm going to get rid of 2 sodiums on the left, 2 sodiums on the right. I'm going to also get rid of 2 nitrates on the left and 2 nitrates on the right. Now, you're probably wondering, why didn't you slash out sulfate or barium ions? Well, that is because I did not have another pair on the product side. And it's going to form the ion that you see there anyway, or the compound rather, for sulfate, the barium sulfate ion. So what we have left over is SO4 2 negative, AQ, plus barium with the 2 plus charge, AQ, producing barium sulfate in the solid form. Those things that we slashed out are called spectator ions. You know, folks that like to be spectators on your channel and don't never like anything, don't never follow anything. They just want to be spectators. Oh, thank you, Giselle. Yes, spectators are those folks that just stare and don't do nothing. Okay, they don't really contribute much. Well, that's what we slashed out. Those spectator ions, okay? Yes, barium and sulfate. Yes, those were what was left over, and then it produced barium sulfate. Now, that's one example. Okay, Tristan said, can you explain how they become spectator ions after you balance it? Well, because they're not contributing anything further to what was left over. So in other words, if you were to put, let me give you an example, okay? If I were to take this solution right here, this is my room spray that I formulated, okay? So if I take this and I added some other things that are not dissolvable in it, those things that did not dissolve, okay, they're going to remain in the bottom. Everything else split up. So because they split up, that results in what's remaining, what's left over. Let me give you another example. Okay, let me give you another example. This one right here, okay? This one right here. You've got potassium iodide plus lead 2 nitrate producing potassium nitrate and lead 2 iodide, okay? That is right, Tristan, that is right, yes. Here's the thing, when it comes to these examples here, okay, you have to split up everything that's aqueous, meaning whatever dissolves in water, okay? Or let's say the solution here. Typically speaking, if I were to combine potassium iodine and potassium 2 nitrate in a test tube, you're going to end up forming this nice yellowish looking substance, potassium nitrate. But then you're going to also see in the bottom of the test tube, or like little particles, you'll see lead 2 iodide. And I may have to do a visual, because I'm a visual learner, y'all. And I'm going to perhaps do a lab demo of the visual of what you see here. Okay. So Key, you got a heavy test load today. Valence electrons, writing electron configuration. Yes, yeah, you got a lot to do, a lot of studying. So what we're going to do here, guys, we're going to go ahead, 20 questions. That's probably one question per concept then. But yeah, that is a lot that you've got to prepare for. So for this problem, what we're going to do, we're going to go ahead and split everything apart. We've got 2 potassium ions, okay? And again, if you know your charges, you know why, I split them up. Key, don't worry about it. You got this. You got this. I have faith and belief in your confidence. Key, you got it. You got it. You're going to split your potassium up from your iodine, okay? That's why I've got the coefficient of 2 there. Because of that 2, I split K and I apart with their ionic charges. Okay, and then that's AQ right there for aqueous. Plus, we're going to do the same thing for lead. Now, lead has a charge of 2. So notice I'm going to put PB with the +2 charge because that is the charge for lead. Then I've got my nitrate, but that 2, because there were 2 units of nitrates, nitrate has a charge of -1. That's where that -1 comes from. All right, Zoe. So are you prepared for your electrochemistry test? Knock it out the box. I'm going to put this as AQ right here. And then we're going to split this up some more on this other side. We're going to take the K and the NO3, split them apart. And then we're going to put the nitrate apart as well. Now, you know what's left over? Your PbI2. And we don't have to split that one up because it is a solid. Okay, because it is a solid. Rayon, this is General Chemistry 1. We're talking about net ionic equations. Now, again, you've got your potassiums, your iodines, your lead, your nitrates. You need to look at both sides and decide which one of these are we going to slash off. So we've got potassium on the left, 2 of them on the left. We've got 2 of them on the right, gone. Do we have an iodine on the left and the right? No. So we're going to leave that alone. Do we have a lead with the +2 charge on both the left and the right? No. So we're going to leave that one alone. So you know what we're going to do? We're going to slash out the nitrates because they're on both sides. So what's left over? Your iodine. So I'm going to write 2I with a negative charge, AQ, plus PB with the +2 charge, AQ, and that produced the PbI2. Lead and iodine married each other to form lead to iodine. No, you stop at this point right here. So this is where you would end it, right here. So if your test question asked you, what were the spectator ions, you would say the potassiums and the nitrates. Those are your spectator ions. Yep, those were your spectator ions. Now, suppose, let me get you one like this right here where it was something else that happened. Okay, take a look at this one. I'm just going to zoom into the equation. Now, if you remember your rules, you will remember a whole lot, okay? Look at what you've got here. You've got hydrochloric acid, AQ, plus ammonia, AQ, producing ammonium chloride, AQ. The question is, do we have anything that we can actually split apart? Take a look at that one. Okay, Zoe says, would HCl fully dissociate because it's a strong base? Well, no, okay, no. HCl is not a base, it is an acid. Okay, it is an acid. And Tristan, you are correct. No, because all of them are, because there's no solids. Okay, so let's talk about this. Right, the rules of solubility. So let me switch the screen real quick to show you all, as a reminder, the rules of solubility. So if you guys remember, okay, this one that deals with ammonia and ammonium. Right here, let me see if I can zoom into that particular one. Ammonium, NH4 are always soluble. Okay, you see that, right? So here's the deal. Let me go back over here so y'all can show you all what's getting ready to happen. When we look at HCl, okay, we're going to go ahead and split them apart, right? Watch this though. Plus chlorine, but you cannot split NH3 up. I just showed you, okay? NH3 must stay together. And then you've got your ammonium, okay, your NH4, okay? And then your chlorine, oops, I'm sorry, y'all couldn't see that part, I'm sorry. Your chlorine gets separated. Now, watch this, okay? Let me zoom it out a little so y'all can see this. So again, we separated the hydrogen from the chlorine. Yes, they split apart. Aqueous split apart. Ammonia, though, doesn't split apart, okay? Ammonium splits away from chlorine. So watch this. Chlorines get slashed off. And so what you're going to find out is that the end result of how we get NH4, which is ammonium, UM, not ammonia, IA, you end up with hydrogen plus NH3, ammonia, producing NH4, ammonium. Okay? So you will have a problem similar to this where you have, again, remembering the solubility rules, okay? Ammonium will split up, but ammonia will not. Ammonium will split up, but ammonia will not. All right. Let's go to, oh, here's a good one. Okay, let me zoom in so y'all can see this. You've got zinc. Solid zinc reacts with copper 2 sulfate to form zinc sulfate, aqueous solutions for both of those, and copper. All right, let's go ahead and do this. What's going to split up? Well, zinc can't split itself up, okay? So you're just gonna write zinc by itself. Let me zoom out so y'all can see the full screen. So zinc is gonna be written by itself plus, and let me make this a little bit smaller because y'all know I'm gonna run out of space. So zinc, right there, okay? So Ishmael, what you're doing deals with electrochemistry. So what we're on, yes, right, which does deal with redox equations. Yes, yes, yes. But I'm gonna show you something though to make this a little bit easier. So the zinc right here, okay, that's in solid form. We're gonna put the +2 there, all right? And then we got copper. Copper has a +2 charge, so that's where the 2 comes from right there, and the aqueous. And then sulfate has a -2 charge, and that's the aqueous, producing zinc with the +2 charge, okay, AQ, plus sulfate, okay, which has a -2 charge, AQ, plus, and then again, copper is by itself with that +2 charge right there, okay? So what you're going to end up doing, yes, that is correct. So even if we do that, okay, you're going to show, even if we erase those, okay, the equation will still stand as it is, where you're going to have to get rid of things that do not, that are the same on both sides. So in this particular case right here, you're going to slash out your sulfates and they're gone. And what do you have left over? These ions here, okay, with your zinc solid plus your copper aqueous, producing your zinc 2 plus aqueous plus your copper solid, okay? So that's what you have, like that's your end result right there for this particular reaction. You just have metals just forming, okay, as a result of this chemical reaction. I've got one more for you guys before I take off to the other part of my day. Let's see, which one do y'all want to do? Yes, Zoe, yes, that is correct. Yes, so you can think about or what's that phrase? Oils, rigs. Let me go back to that one. We'll end on that statement right there. And I'll finish these later. Yes. Oils, rigs, oxidation, and reduction. So oils, rigs means oxidation is losing electrons, reduction is gaining them, okay? And I shouldn't put the S on the end. Oxidation is losing, reduction is gaining, okay? So on that note, guys, it is 1 p.m. Eastern Standard Time, my time. I give you guys tutoring, free tutoring every Monday, Tuesday, Wednesday, Thursday at 12 noon Eastern Standard Time. So if those of you guys that need further help, by all means, come on my live with me. Come on my lives with me. Also, don't forget that you can subscribe to my YouTube channel to get further clarity on some of these practice problems. So when I don't post these videos on TikTok, you can always go to my YouTube channel. You're welcome, Zoe. You're welcome. And thank you guys so much for those beautiful roses and all those lovely shares and likes. I really appreciate you guys for contributing your time with me every Monday, Tuesday, Wednesday, Thursday. And if you guys want to join me again, I'll be here on Monday. All right, guys, you all have a good one and take care.